What happens in a typical factory is that often many bolts need to be tightened in a specific sequence. Imagine your wheel bolt. You don't tighten in a circle, you tighten in a zigzag. This is a bolting tool. You would typically attach a mechanical fixture to this with some measuring devices. Think of a linear measuring device that can measure in a few directions. And you'll have an X, Y, Z coordinate when it's in a position. And only when that X, Y, Z coordinate is correct for that particular bolt do you switch the bolting tool on. In this case, it's Wi-Fi, it could be a cable, it doesn't really matter.
And the tool turn on if you're in the wrong spot?
No. So if you're in the wrong spot, the tool doesn't turn on. And in order to achieve that today, you have to have a big mechanical structure with all of these sensors in there to detect the position of the bolting tool. What we've done is we've used computer vision AI. In the same way self-driving cars are able to detect objects in front of it and make a decision, we're able to determine this bolting tool as an object in 3D space, know its coordinates of the socket, and only when the coordinates are in the right place do we switch the bolting tool on. So now that physical device that would have been there is now a virtual device. Hence the term, we're creating virtual devices. And now we can control the position of the bolting tool independent of that physical device being there.
How do you know where the socket is? The socket surely doesn't have a sensor on it.
No, the AI is detecting, is identifying it. It knows what the socket looks like. It knows the position of the bolting tool. It knows my hand is covering all of this stuff. And so that's the power of AI. The more data I feed it, the more different lighting conditions I feed it, the more different hands I feed it, the more accurate the model of this bolting tool becomes, and I'll be able to detect it in multiple scenarios.
Skin color, does that learn
Skin,
as well?
yeah, skin color makes a huge difference. We've actually...
More texture, yeah, so more light bouncing off.
Oh, well, it doesn't matter. It depends on what you've trained it. So if you trained it, we actually have a video we did 2 years ago where Jason trained his hand going into the bins with his hand. And when I came to do a video of it, it didn't detect my hand. And that's what you call bias in data. So if you train it on a certain data set, that's all it knows. And it thinks that that's right. One way that you can use bias is, for example, we want to make sure that operators are always wearing their safety equipment. So we've deliberately introduced a bias into our hand model to only detect people with gloves on. So we're actually excluding a set of data on deliberately, in other words, creating a deliberate bias so that we can ensure operators are always working with the glove on.
So that's glove, you won't be able to reach
yeah.
the bin.
No, well, it won't detect anything. You won't, if you pick up the bolting tool, it will assume there's no bolting tool, as an example. So that's how you can use bias to your advantage to control certain things. Yeah. That's maybe more useful for the video. Here's another Thursday thought. Probably a little bit more.